Hi guys, my name is Ibrahim Goolam, and I will be giving you some feedback on the 2020 HSC Extension 1 Maths feedback on question 12. Now, what is interesting is that of the 5 questions that make up question 12, all but one assess contents of the new topics that were introduced very, very recently to the HSC syllabus. The exception was, of course, question 12A, which was a typical textbook type of question involving the straightforward mathematical induction proof. I'll just share that with you on the screen. These slides have been structured so that the question appears on the top with the suggested solution appearing on the left-hand side of the screen, and then the essential feedback or some of the more salient points appear on the right-hand side of the screen. So as far as question 12A was concerned, the students basically needed to show their substitution when verifying for the base case. They, of course, needed to state very clearly the assumption and then use that assumption to prove that the claim that is made in the question is in fact true. And of course, we needed to see all the steps in the proof. Now, in better responses, what students did is that they dealt with the left-hand side and the right-hand side separately for both cases, n equals 1 and n equals k plus 1. They clearly articulated the induction hypothesis. They also stated exactly what they were trying to prove when n is equal to k plus 1. And in the body here, where the calculations were actually done, they actually used factorization rather than expanding when they were proving for n equals k plus 1. Areas for students to improve, they include some of the following. The need for them to understand that only one term on the left-hand side is required when n is equal to 1. There were lots of problems with regards factorization and using of brackets. They were not exercising care when they were using brackets, opening brackets and not closing them. Factorization, as I said, was another problem. Many of them didn't ensure that each of their steps was algebraically correct. Some of them chose to use sigma notation and used it incorrectly. And then, of course, many of the proofs were not set out in a logical sequence. And many students, and this was actually quite surprising, this being a proof, they were attempting to do the proofs by working they must work from one side, of course, to the other, and not manipulate both sides simultaneously by canceling terms from both sides. And this created lots of confusion. So that was question A. Question B was essentially a binomial distribution problem. And in this problem, of course, the question appears on the top there. The suggested solutions are on the left-hand side, as I mentioned. And in this problem, of course, the first thing that we expected them to do is to understand that we are dealing with binomial probability, and the parameters involved are n equals 100 and p equals 0.6. Of course, they needed to indicate that they understood the relationship between variance and standard deviation for the B part. And they were needed to actually link the probability to the standardized z-scores in normal distributions. Now, this was relatively straightforward because much of the information here was in the reference sheets. And in the better responses, the students used the empirical rule that is found in the reference sheets rather than attempting to actually calculate the probabilities from the z-scores. The areas for the students to improve include the following, and these are just some of the points. They need to focus on the contents and the correct use of information related to statistics in the reference sheet. Many of them actually didn't do that. And also to ascertain when and how to use the standardized z-scores to find the probabilities for normal distributions. The next question, question C. Sorry, I've just gone a bit too far, I'm sorry. Yeah, there we go. This one was a typical pigeonhole principle problem. The question, as you can see, appears on the top, on the left-hand side, and a suggested solution is here in the bottom. And in this example, the first thing that, of course, they needed to do was to evaluate the correct expression for 8C3, the number of possible choices in the problem. What was needed for them to identify and quantify the pigeons and the pigeonholes. And many had problems with that. And then, of course, we expect them to understand and explain how the principle, the pigeonhole principle actually applies in this particular scenario. In better response, students were able to work out that the minimum number of a minimum number of 393 students were needed to ensure that at least 8 students passed exactly the same 3 topics. Others established that 392 pigeons were needed to equally fill each of the pigeonholes with 7 pigeons, and the remaining 8, to make it 400, as the question asks, could be added to any one or more of the pigeonholes. So their interpretation of the problem was actually well documented and well articulated. The areas that needed improvement, as far as we were concerned from a marking point of view, was the inability of students to clearly explain the the pigeonhole principle, their lack of understanding of the sealing principle, or why we round up when using the pigeonhole principle. And some of them, just instead of using the formula, that means the rounding up formula or the sealing formula, with the hope of getting the correct answer, they should really be concentrating on solving the problem using logic and sound reasoning. The other important thing, of course, is that they need in their curriculum, in their classes, to practice interpreting worded problems, which is what this really was. And of course, to make sure that they thoroughly revise the year 11 content, which is where this particular topic is covered. So they should really be ready for topics in year 11. The next question was D. And this was a problem involving, as you can see, the product of 2 trig functions, the product of 2 trig functions, the integral of them, a definite integral. A suggested solution is on the left-hand side. Here, of course, we expect the students to understand that how to use trig identities from the reference sheet. Okay, and then to also know the rules of integration, that is that the integration of products is not always equal to the product of the integrals. And of course, to make sure that they check the results when integrating trig functions, paying particular attention to the signs and of course to fractional coefficients that were involved. Now in better responses, and this was reasonably well done actually, students used the appropriate transformation. They actually took the products and wrote them as sums and then did the correct solution in a concise manner. However, as far as the weaker students are concerned, the improvement needs to be made, and that is in recognizing when to use the trig identities from the reference sheet, of course, and of course to exercise care when integrating trig functions, paying particular attention to signs and fractional coefficients. This was actually very badly done by some students. And then finally, in question E, which involved a problem involving differential equations, a gradient function was given, and the task was to actually find the curve that actually fits through the desired point, and the point was 1, 0. The solution, as you can see, appears on the left-hand side, and the result happens to be a unit circle with a radius of 1 with its center at the origin. In this problem, essentially what we needed was, of course, the need for students to understand the concept of separation of variables when dealing with differential equations. And of course, not to assume that the subject of the equation which results must be y, or that the function must be linear. Many of them actually thought that that was supposed to be the case. In better responses, students used a definite integral to arrive at the solution, thereby obviating the need for work to be done with the constant of integration, and that was pretty smart. And then, of course, others realized that the solution, or most of them who did a good job of this, realized that the solution does not have to be a function. And in fact, it's, as you can see, a relation between x squared and y squared. Areas that needed to be improved is understanding that in differential equations, one should not integrate where there are multiple variables on one side. The other point that needs to be elaborated in class and teaching is avoid basing constants of integration on both sides. Many students did this, and this caused a lot of confusion because they couldn't evaluate the constant of the primitive. And finally, as is always the case, poor algebraic skills, especially when dealing with quadratics and negative numbers, when it came to substitution and solving quadratic equations. And that's my feedback. Thank you, guys. Have a good day. Bye.